Hello everyone, so this is going to be a quick video on some basic programming tips in Python. So what we're going to do today is we're basically going to translate anything we do in Python to something that we would do in Excel. So we're going to go from Python to Excel. Please keep in mind that we can do an infinite many things in Python, and everything that we do in Excel can also be done in Python, but that doesn't necessarily mean that the reverse is true. Not everything that we do in Python can be translated into an Excel spreadsheet. So keep that in mind as we're going out throughout this video. One of the first things that I like to do, so Python has a number of built-in functionality associated with it. So for example, I can add 1 plus 1, and that will equal 2. But there's an almost infinite number of libraries that are available online that increase this level of functionality. So one of the main ones that we tend to use in this course is the numpy. And so if I want to import a library, I might say input numpy. And then I like to name my library. So typically I'll say import numpy as some name. In this case, I'll call it np. And we can create some sort of variable, say variable equals 1, which corresponds to me creating some variable in Excel and basically giving a cell name a value of 1, except in Python, I've created this value with some sort of variable name. I've called that variable name var. Another thing that I could use the basic Python programming language for is to create something called a list. And so a list is typically denoted by brackets, and so I can give it two integers, 1, 2. I could also create lists of lists, and so I could give it two lists, 1, 2, and 3, 4. And I can print A. And what that might look like in Excel is something that has two lists, 1, 2, and a second list, 3, 4. And it's something that looks like a 2 by 2 matrix, but actually in Python, lists aren't typically used for linear algebra calculations. And so that's when I might leverage the numpy library. And so I can convert this list into a numpy array, and that numpy array takes inputs that are lists. And so then if I print that numpy array, I would find something that looks a little bit more like a matrix, and it's something that I can use for matrix multiplication calculations, for example. And so this looks like something that has 1, 2 rows and 1, 2 columns. And so it's a 2 by 2 matrix. There's a number of different numpy functions that I can also leverage to create large arrays. So for example, I might want to create a vector A that's an NP, a numpy array that's made up of zeros, and I can give it some sort of size, let's call it 4. And then if I just print A, it would give me a vector, if I go back to my Excel spreadsheet, that's 1, 2, 3, 4, basically is of size 4. It has 4 elements in it, each with 0. If instead I wanted to make some sort of column array, if I were to look up this zeros command on Google, I would see a number of different sort of inputs associated with it. So another sort of input that I could pass it is something called a tuple. A tuple is associated with another set of parentheses, and so if I'm passing the single number 4 to this np.zeros array, a tuple allows me to pass multiple numbers that still represent one number. So when I look up this np.zeros array on Google, it'll tell me that I can also pass a tuple, and maybe what I want to say is that I want to pass something that has 4 rows and 1 column. And so if I print B, it is now a matrix that is made up of 4 rows and 1 column because I've passed that tuple. Remember, this is all being passed together. That's made up of 4 rows and 1 column. And so that's going to be a matrix or a vector that's 4 long, made up of all zeros. And so I can also do math because it's associated with these numpy arrays can also do math. And so what I might do is I might multiply A times B, which will result in some sort of 4 by 4 matrix, or I could use something like A dot B, which actually does vector multiplication, in this case the dot product of A times B. So there's a number of things that I can use with this numpy array. I can also say that instead of maybe creating a vector made up of only zeros, maybe I want to create a vector C that's made up of ones. So if I were to look again at this numpy library, there's also another functionality or another thing that I can call that creates a vector of ones. And maybe I want this to be, and again, I'll pass it a tuple, 2 rows by 5 columns. And print C. And now what you'll see is that it is a vector of 2 rows and 5 columns. And so if I go back to my Excel spreadsheet, that corresponds to something that looks like 2 rows and 5 columns. So this is nice, but let's do a little bit example. So I'm going to go to Chopra's book, and let's see if we can actually input some sort of forcing function P that's discretized with respect to time, and it'll be basically time will start at 0 and end at 0.6 seconds. And so this P function is going to be created by this sort of sinusoidal equation, and it's going to take inputs T. And so what I can do is I want to create some sort of array that starts at 0 and ends at 0.6. Well, there's a really nifty array function that's associated with the numpy library, and it's called the linspace function, and it basically takes an initial value and a final value, and then you give it some sort of size. And so maybe in this case, I just want to give it a size of 7. And so if I print T, that will create an array, a numpy array, that starts at 0, ends at 0.6, and has 7 elements, or a size of 7. And so I'm going to just write that over here, except I'm going to write it just a little bit simpler. It's just going to be something that starts at 0, ends at 0.6, and basically increments by how many number of indices I want. In this case, it's just 0.1. And so this is the time array associated with this new vector that I've created in Excel. But say I wanted to grab a certain one of these numbers. So let's say I wanted to grab T 0.4. So how would I grab this number? Well, each one of these elements is associated with an index. And I like to call my indices J. You might also see them called I in some cases. And in Python, these indices, they start at 0, and they basically just increment by 1 until you reach the size of this array minus 1. So it'll start at 0, it'll end at 6, and remember there's still 7 elements in this time array. And so because Python starts at 0, it ends at 7 minus 1, or 6. So if I want to grab this 0.4 value, what I might say is I want to return T at j equals 4, or T at index 4. And how you implement some sort of index is with these brackets, and so T at 4. And if I print it, what you'll see is something that looks very, very similar to 0.4, but it's not exactly 0.4. So this is a result of computer error. And so your computer is constantly moving things around in memory and reading and writing things to different places in memory. It also has a certain number of bits associated with each of these values. And so computer math is not exact. It is approximate. And so just by calling something or pulling something out of this array, I'm ending up with some sort of error. Okay, so now let's go back to our example. So I want to create some sort of P function that goes from time equals 0 to 0.6. And so the mathematical equation of that is 10 times sine, according to that little example, times pi times that time array over 0.6. That's what I'm reading in basically exactly from this example here. That's what my P value is. And if I go to run this, what I'll find is an error, and it'll say the name sine is not defined. And that's because sine is not a part of the initial Python scripting language. And so I might have to import another library, let's call it math. And I'm going to input it. I'm not calling it math. I know that this math library exists, and I'm going to import it with the name M. And so let's see if I call this m.sign, and then it says name pi is also not defined, and so that's going to be called m.pi. And then it says something very interesting. It says only size 1 arrays can be converted to Python scalars. And what this means is that you're taking this array t and you're trying to do some matrix math with it. Well, the math library doesn't support matrix math, but we're in luck. The numpy library supports math. And so I can use the sign function and pi function from the numpy library, and I can use that to calculate p, and then I can print p. And so what this did is it basically is taking this entire array of time and creating a new vector that we've called p out of that time, and it's doing it all at once, and it's saying that that thing is associated with this math function 10 times sine of pi times all of time over 0.6, and it is doing it all at once. So even though I'm saying it looks like it was doing it one at a time, in this case it's doing it all at once. And you'll see that they match up, and even Excel has a little bit of math error.